Okay, let's talk about mixtures and pure substances. All matter can be divided into groups. So, what is matter? Matter is anything that you can hold in your hand. So, anything that has a mass means that it has a weight, it's made up of atoms or particles, and it also needs to take up space. So, if you put it somewhere, you can't put other objects on top of it. Like if you put a glass of milk down, you can't put your cookies in exactly the same spot because the glass of milk takes up space. You can't overlap them in the same spot. So is everything made of matter? No. Like, no. There are things like energy or like your name or your thoughts um, that we talk about in English, but they're not made of stuff. You can't hold your thoughts in your hand. Um, you can't hold your name in your hand. So, like, essentially, my summary always is like, if when you think of something, if you could hold it, it's probably made of matter. And if you can't hold it, it's not made of matter. Okay. So, matter has to be one of two things. It's either got to be pure or a mixture. So, what's a mixture? A mixture is more than one substance, so like more than one thing. So, let's say I take chocolate and I take milk and I stick them in the same glass. That's a mixture. The properties of a mixture have to be similar to the things that you mixed, right? So if I took chocolate and milk, I need it to taste like chocolate and milk. If I put chocolate and milk together and then all of a sudden you say, whoa, that tastes like strawberries, that is not a mixture. Something crazy has happened. That's a chemical like reaction has gone on. So mixtures, like if I put, say, tomatoes and carrots and lettuce together, I get a salad. That's a mixture. It doesn't taste like only tomatoes or only carrots. It's like a mixture of all of them. A pure substance, on the other hand, has to be made from one thing only. There can be different kinds of atoms in there, but if there are different kinds of atoms, they need to be bonded together. So let's take carbon dioxide. Carbon dioxide, it's got carbon, it's got oxygen, but they are stuck together. Water is made out of two hydrogens and one oxygen, but they're not hanging out. They are bonded together. H2O, they are all one thing. Okay, so matter, if you're pure, you have to be an element or a compound. So let's take a look at that. Compounds have more than one element that has to be bonded together. They can't just be thrown together or hanging out together. They need to be bonded. The same way that if you go to a dance with someone, you haven't married them, you're just going to a dance with them, right? You're going on a date. But if you get married, that's a bond, that's a different thing. If you are a compound, you have a chemical formula. So if I asked you what's the chemical formula of chocolate milk, you'd say, well, I have no idea because chocolate milk does not have a chemical formula where water does. Water is two H's and one O, or glucose is six C's, 12 H's, and six O's. They have chemical formulas because they are compounds. Compounds have a definite composition. They have a definite recipe. So if I asked you how you make chocolate milk, it's going to be different than how I make chocolate milk because chocolate milk is not a compound, right? If I asked you how do you make chocolate chip cookies, your recipe can be different than mine is because chocolate chip cookies are not a compound, right? Compounds like water have to have a set recipe. Water is two hydrogens and one oxygen. Carbon dioxide is one carbon and two oxygens. It's set. Okay. If you're pure, you don't have to be a compound. You could be an element. So, what's an element? Elements are one type of atom, and you can find them on the periodic table, like neon or gold or hydrogen. They're examples of elements. At this point, we have about 120 elements that we know of, and you would have to spot it on the periodic table. If you're not pure, then you are a mixture. And mixtures come in two types, homogeneous and heterogeneous, or heterogeneous, however you want to say that. So homo is a prefix that means the same, and hetero as a prefix means different. So mixtures are identified by how they look. It's not what's in them or anything else. It's when you look at them, how do they appear? So a homogeneous mixture or homogeneous mixture will look like one thing, right? It's going to look like one thing, even if there are multiple things in there. So some examples are milk. Milk is made out of water, protein, calcium, vitamins. There's probably bacteria in there. There's all kinds of things. But when you look at milk, you see one thing. Tap water. The water that comes out of the tap has water. It's probably got iron, maybe some fluoride, maybe some calcium, maybe some carbonates. But when you look at tap water, it better look like one thing. If your tap water has things floating in it, or if you can see things in your water, then you should get that checked out. American cheese. American cheese is a bunch of different chemicals, but when you look at it, it looks like cheese. Okay. Heterogeneous mixtures are different. They look like more than one thing. You should be able to see phases or levels or regions. You should be able to see different parts in there. So an example is salad. You look at a salad, you go, oh, look, there's some lettuce, there's some carrots, there's a tomato. Or if you look at a chocolate chip cookie, you can say, oh, that's the dough, and this is the chocolate chip. Like there's two different spots. With a sandwich, you could say, oh, there's a bottom piece of bread, there's some cheese, there's some ham, there's another piece of bread. You can clearly see the layers. Now, if I take a heterogeneous mixture like a sandwich and I throw it in a blender, well, then I can...
Miss Mazes, please return back to Miss Rawls. Miss Mazes, please
Sorry,
return
guys.
back to Miss Rawls.
Okay,
Thank
so
you.
if I threw my sandwich in a blender, I could turn it into a homogeneous mixture because then it would look like a goop. Or if I took my salad and I threw it in a blender, I would have a smoothie. And depending on how much you blended that, it would look like one thing. It would be homogeneous. Okay, mixtures. We said they were homogeneous and heterogeneous. If you are a solution, that's a subset of homogeneous mixtures. And solutions are mixtures that are so well mixed that they are clear. You can see through them, right? So milk is a homogeneous mixture, but you can't see through it. Gatorade. Some Gatorade is clear, that they are solutions, and some Gatorade is cloudy because of the different like sugars and electrolytes that they put in. And if it's cloudy, you can't see through it, then it is not a solution. Air is a solution. Air is a solution because when you look through it, it's clear, right? But air is actually nitrogen and oxygen and carbon dioxide. It's a mixture of things, but it's a solution because you can see through it. So here's the whole thing all put together. Matter can be either a mixture or a pure substance. And if you're a mixture, you have to be homogeneous, you look like one thing, or heterogeneous, where you look like two or more things. And if you look like one thing and you're clear, we're going to call you a solution. If you're not a mixture, you must be a pure substance, which means you're a compound or an element that can be found on the periodic table. So let's take these four things. Aluminum foil, Coca-Cola, pure sugar, and Newman's Own balsamic vinaigrette. Two of these are pure substances. Which ones are pure? Now the thing says pure cane sugar. Now that would be a dead giveaway, except that it's marketing, right? So you always have to be careful about marketing because people can tell you things that are not true. But in this case, it is pure. Aluminum is a pure substance that is an element. You can find it on the periodic table. And sugar has a chemical formula. That is sucrose. It's C12H22O11. They're all bonded together, those C's, H's, and O's, and so that is pure. The other two, Coca-Cola, has an ingredient list. If you look in the bottle, there's a list of like 15 or 20 ingredients. Some of them are probably secret, which means it's a mixture of things. And Newman's Own also has a bunch of ingredients. You can see spices in there. You can see oil. You can see vinegar. So it's got to be a mixture. So let's take the two mixtures. What kind of mixture is the salad dressing? So if you look really closely, let's see if we can zoom in here a second. There's a top layer and a bottom layer. Oops, let's zoom back out. If there are layers, that thing is heterogeneous. You can see different layers. If I zoomed in even more, you could probably see the spices that were floating in there. The Coke is probably homogeneous. If you look at it, look through your Coke, it's going to be a clear brown liquid. But if you shook it up recently and you can see bubbles on the inside, that makes it heterogeneous. So some of these questions are going to be hard to answer unless you can physically see what you're looking at, right? So if I just say, hey, is Coke homogeneous or heterogeneous? You should ask me, like, well, are there bubbles in it? Is it flat? Did somebody shake it up? Like, there's all kinds of questions you could ask. Okay, let's take a look at these pure substances. What kind of pure substance is aluminum? It's an element. It's number 13 on the periodic table. You can spot it. Cane sugar, it's got a chemical formula. If it's got a chemical formula, that means it is more than one element bonded together. That thing is a compound. All right, so let's go back one last time, right to there. So here is your breakdown of the matter, and we're going to use these to take a look at some stations tomorrow, and you're going to use these definitions to look at a worksheet today.